Suppose we wanted to compute 3 to the 100th in mod 7. Now this will give us an extremely large number, and hypothetically we could compute it by multiplying 3 by itself over 100 times. However, this would be extremely tedious and this would take a long time. However, there's a better way where we use fast modular exponentiation, which will allow us to compute powers much more efficiently. So let's go over how you can do that. Okay, going over fast exponentiation, one of the core concepts is that if we had, say, 9 in mod 7, this is actually congruent also to 2 in mod 7, since 9 has a remainder of 2 when dealing with mod 7, of course. So, how can we use this to our advantage? I want you to think about that for a quick second and then come back. Okay. If you said moving the powers around or had an idea similar like that, such as doing 3 to the 2 to the 50, then you would be correct. Because when we do this, this ends up becoming 9 to the 50, which, remember what we said, was congruent to 2. So we can replace the 9 altogether with 2 to the 50. Now, is there an even better way, or can we reduce this even more? The answer is yes, we can keep going. One of the ways that we can break this down further is by continuing to play around with the rules of exponents in algebra. So similar to how we did 3 squared to the 50, we can keep doing something similar to that. We just have to find the right numbers. And the reason, actually, I didn't go over this before, but the reason that we are able to do 3 squared to the 50 is because when you have an exponent with in parentheses like this, and you raise it to another power, is these powers multiply. So this is actually also congruent to 3 to the 100, which I should have explained earlier, but it's okay. Okay, so now reducing further from 2 to the 50. How can we do this? I think right now the cleanest way that we can do this is that if you think about 2 to the 3, that equals 8. And 8 in mod 7 is actually, here, 8 in mod 7 is actually congruent to 1. And with exponents, that'll just end up being 1. So let's do that. If we do 2 to the 3, then how can we still make this equivalent to 2 to the 50? Well, if we take 16 times 3, we end up getting 48. So we can put that up here. But then we're still missing 2 more 2's that need to be multiplied by it. So what we can end up doing is just do 2 squared. Or if you wanted to, you could just do 2 times 2. But we'll go with 2 squared for now. And that brings us to 50. Now, the way I found the value of 16 is you honestly just have to mess with this a little bit. Start thinking of numbers that, would work easily. But I think the better way to approach this is first think of how can you get 1. How can you reduce to 1? And the easiest way with this is 2 to the 3. So now that we have this, recall that this is this equation is actually equal to 8 to the 16 times 2 squared, which is congruent to 1 to the 16 times 4. Okay? Because you recall, the 8 is congruent to 1 in mod 7. Okay, now this 1 just ends up becoming 1 because the exponent doesn't do anything here. Times 4, well, that just ends up being 4. So this 3 to the 100, it actually just ends up equaling 4 in mod 7. And then you just computed this with fast modular exponentiation. Now let's look at an example where we're trying to find what x is congruent to in mod 9. So we know it obviously at the moment is congruent to this statement, but we want to actually get this within the bounds of 0 is less than or equal to x less than or equal to 8. Or you could just say 9. So let's start off by thinking about what 8 is in mod 9. 8 is actually congruent to 1. Oh, I'm sorry. 8 is congruent to -1 in mod 9. Okay. And 7 is congruent to -2 in mod 9. So I think that these reductions, although negative, will make this easier right away. So let's start with that. We have x is congruent to 2 times -1 to the 3 plus -2 to the 2. And then this is going to get us 2 times -1 plus, and this cancels out the negative, so we're left with 4. Moving over here, we have x is congruent to, to -2 plus 4. So x ends up being congruent to 2. So that was a pretty quick solution. Some other ways that you could have done this is you could have went with uh, 8 squared equals 64. And then, um, oh, what was it? And then realize that that has a remainder of 1. Yeah. And okay, I'll do that here. We're gonna do it with the way that I just explained it. So 8 squared equals 64. And if you think about this, 9 times 7 equals 63. 64 will be congruent to 1 and 9. So one way we can do this, we can do x is congruent to 2 times 8 squared times 8. And then we'll worry about the 7 squared in a second. What this ends up being is 64 here, which ends up just being 1. So now I can do x is congruent to, let's say 16 here, plus 7 squared. This 16 will end up being 7. It has a remainder of, because if you do this, you get 7. So we can do x is congruent to 7 plus 7 squared. And then 7 squared is 49. So what is a close remainder to 49? Well, 9 times 5 is 45. So 7 squared, which is 49, will lead us to x is congruent to 7. And then reducing 49 here, remember that 49 minus 45 equals 4. So we have a remainder of 4. And then we get x is congruent to 7 plus 4 equals 11. So x is congruent to 11. Okay. And 11 in mod 9 is equivalent to 2, has a remainder of 2. So x is congruent to 2. Okay, to quickly recap, to do fast modular exponentiation, always think about how you can get to having a remainder of 1 and then extracting powers, sort of like this. It doesn't necessarily have to be 2 in this case. It could be x to the 3 with n divided by 3, or even x to the 5 with n divided by 5. But always remember that these multiply together, and this is actually the same as just saying x to the n. Okay? So, break down the exponents in a way that makes it easier to handle. And then also remember that if, say, we're in mod 7, then, let me not write that. Say we're in mod 7, then 9 is congruent to mod 2. And if we have 9 to the n, then we can actually just end up writing this as 2 to the n. And that will help you immensely to to get through these quicker. Always just think, how can I reduce? How can I reduce? How can I reduce? And if you find an opportunity where, let's assume we're still in mod 7, and we find a way to get to the number 8, then we know that that's congruent to 1 in mod 7. And say we have some large number like 100, and we're in mod 7, then this is actually the same as just saying 1 to the 100, and that just ends up equaling 1. So always try and find how you can get to the remainder of 1, and these problems will fly by way quicker, and they'll be a lot easier for you. So that's it for today. Thank you for watching. I really appreciate your support. If you could like or subscribe, I'd really appreciate it. Let me know in the comments if you need another video, different explanation, better examples, whatever it may be. And thanks for watching.